object. An object is an instance of a class. Remember we talked about structures, and structures occupy no memory, right? They're just a template, and I use that term in quotes. Just a cookie cutter or a template for the structure of what the data would look like if we had one, right? So a class is like a structure, and an object then is the variable, the actual instantiation, the memory occupying thing for the class. Justin, you have a question?
Looking at the type of dog, the dog would be the object, the class would be animal then?
Well, what we're talking about is dog is the class name.
Okay.
Okay.
Object would be a
I
lady.
have a dog at home, and her name is Annie. Okay? And she has attributes and so forth. So she is an instance of the class dog. Okay? She has attributes. She's an actual instance of this amorphous, theoretical, structural thing called a dog. We know that dogs have 4 legs, they have a head, they have a tail, etc. Those are attributes. They bark. That's a method, right? And so on. So dog is the class name, and Annie is the instance name for that class.
So an instance would be Labrador or...
Well, a Labrador is a specialization of the class.
Okay.
Right?
Okay.
Annie, who happens to be a dog, a specific hardcore overweight dog that lives at my house, okay, is an instance of class dog. Now we can look further and specialize dog into Labrador. We can specialize it maybe even into black lab if they're different from chocolate labs or whatever.
But it's specialized.
But those are specializations of the basic class.
Okay.
Because we also have other kinds of dogs, chihuahuas and shepherds and so on and so forth. Okay? Those are still classes, not an actual instance. Right? If I've got Lassie, Lassie is an instance of a collie dog. Okay? Is that clear? Did I answer the question?
Thank you.
So, attributes or properties, they are made up of members, data members, things that describe the actions, what it can do, how we get to it, how we get out of it, what causes Annie to bark, what causes the dog to bark, what causes to eat, and all of those actions, the activities that a dog might do are methods. And when we talk about the attributes, data members, how tall, weight, color, those kinds of issues. Okay? It's difficult to talk about a class of something that is very abstract. Okay? It's easier to talk about a class of something that's real, something that is physical, like a table or a computer or a desk or a chair or a cup of coffee or a dog or a horse or what it may be. When we talk about something like religion, it's difficult. That's not really an object or a class. But one could, by some stretch of the imagination, make that into a class. But it would be you'd have to really work at shoehorning that in. Okay, so let me continue this thread. The object is the center of the object-oriented paradigm, usually a noun, that's a descriptive word, right? What it is. There are examples of user-defined data types. Clearly a class is a user-defined data type. And they're characterized by attributes and methods. maintain a state. The dog, and therefore Annie, has a particular state at a given time. Usually asleep, okay? But sometimes not. So the state is represented by something, and then something maybe changes the state. That might be some sort of a method. Behaviors. What causes this change of state? What is the behavior? Randy used to have a dog by the name of Webster, and so Webster is an object, right? Class, dog. Webster, bark, sit, fetch, and shake. So those are things that, actions, behaviors, if you will, that might describe that object. Functions, methods, they're often referred as member functions or member methods. When we talk about member, that qualifier is really important because bark only refers to Webster if we have the object Webster, right? Now, most all dogs can bark, right? I think there's some breed that's born without a voice box or something like that. But in any event, a behavior of barking is something that refers to the class dog and also refers specifically to the member, not to the member, but to the object, Randy's dog or Don's dog or whatever it may be. We have access to modify the class attributes. If I want Annie, the object, to wake up, all I really have to do is rattle my keys. So the interface to that behavior is a sound, right? So we have some kind of interface that we want to be able to talk about that changes the state. And only that interface does that behavior. Is that clear? And it only refers to rattling keys doesn't affect my wife any, it only affects my dog. Okay? So it's limited to specific classes, that behavior and that input. So classes, similar to structures, in fact they are the same. Acts as a placeholder for data, no memory allocated until a variable is declared from the class. So it's said to be instantiated. Instantiated becomes an object. So when we instantiate a class, we make an object out of it. Class methods provide this interface. So I might have a method called shake keys, rattle keys. And that's providing us an interface to get some behavior, some change in state. How methods are implemented is usually hidden from the user. We call this implementation hiding. How many of you know how CIN is implemented? The details of it. Does anybody care? Most of you probably don't. I do. I care about it because I like to look at the lower stuff. But most of the time, we just want to use it. We want to consume it. We want to be the consumer of this behavior or this methodology. So the details are purposefully hidden so that I can't reach in and get some other behavior out of this thing, right? That's issue one. Issue two, probably more important, is I don't care, right? I don't want to know. I don't want to know. But at the same time, this issue of putting a barrier up, we're not talking about security here. We're not talking about security. We're talking about Justin making some call, changing some variable, wasn't intending to do it, but suddenly crashes the program that he's working on that Jeff had, right? Being able to make that kind of change affect Jeff's program is terrible. You didn't intend to. You happened to call the variable the same name. You set your init variable to 0, and it turns out that the init variable he was using in his program for a whole other thing. A side effect. You all understand, you have been told by me and others, we don't use go-tos. Why? You see, we don't use go-to statements. Because it ties together and introduces side effects in larger programs. If I can go into the middle of any kind of a program, anywhere in it, from anywhere, all of a sudden that whole program is open for change by anybody, right? Anybody that is writing code. I'm not talking about security here. I'm not talking about encryption keys or any of that kind of stuff. Simply talking about other programmers coming in, adding code, having a side effect, unintended. So this implementation hiding piece allows us to decompose. It is what allows me to say, Dwight, go off into your closet, into your cubicle, and write some chunk of code. As long as these two guys have the appropriate interface to your code, everything's cool. And your implementation of how things get done is hidden. Is that clear? Very important to be thinking about that. So I only need, as a consumer, sometimes we use this word user as, oh, that user down there that doesn't know anything about programming, I've never even sat in front of a computer, and now I'm a user. That's not the user we're talking about here. This is another programmer. This is another programmer who is using the code that you've written to build something else. Clear? So the user of a class need only know the name of the methods and not how they are implemented. String toke. You could look at the detail on string toke, but all you want to know is it's called string toke. What are its parameters? What's the types? And how many in what order? Right? That's all you want to know. Same issue here. Inheritance. I like inheritance. My daughter's going to like it even more. When I kick the bucket, she inherits something, unless I spend it all in advance. The term means that, yes, it means a lot of different things, but it refers, in this case, inheritance, a huge benefit to programmers. When I said you guys are writing code standing on the shoulders, standing on the backs of other programmers that have written stuff already, right? You are, in one sense, you are inheriting their work. And then you can extend off of that to make a better program, to do more, to be able to do more efficiently or whatever. Not have to rewrite what's already written. Inheritance is a specific kind of approach. When we define a class, wouldn't it be neat that class is encapsulated, it's got data members, it's got methods that make it work. Now, I can write another class that says, oh, I know that code already exists. I just want to add to it. Okay, I want to inherit all that functionality, all that ability, and then extend that ability. In 136, you'll take something like cin and extend its functionality. Right now, if you said cin and you gave a name of a structure, would it work? No. You've got to go through and identify each of the primitive members that CN already knows about, and say, oh, read a string, or read an integer, or read a floating point. But you can, in 136 you will, extend the capability of CN and just be able to say CN, here's a structure, and it'll get the first name, last name, ID, and all that stuff for you. You have inherited CN's functionality, and you have extended its functionality. We're going to introduce in a little bit this notion of a C-string, using the C-string class, which does exactly that. Okay, so inheritance, let me back up. Why do you suppose this stuff is important? Because we're philosophical and we are philosophy majors, and well, that's a better way of doing things, and it's nicer and it makes more sense. And is that the reason?
So like what you're just saying, so that we can
So what?
look at other code and
So what?
it's all encapsulated.
You all know who Bill Gates is, right? Do you think that he made his money by letting you do whatever you wanted to do any old way? Bill Gates has a reputation while he was working of being a very hard-nosed, sharp-penciled kind of a guy. Tell me exactly why I want the most bang for my buck. So I'm going to hire the three of you $100 each per hour, but you better work efficiently. You better work effectively. And so if you're going back and rewriting everything that CN already does, and I pay you $100 an hour to do that, I'm wasting my money, aren't I? So it really does come down to dollars. It comes down to dollars. We could not get done, in addition to dollars, we couldn't get done the job that needs to be done if we can't partition. We can't subdivide and allow multiple people to work together. So that's another very important piece here with respect to inheritance. Sometimes we just say it simply as, why reinvent the wheel? Stuff's already out there, and by the way, when it was invented with the intention, it was designed with the intention that you would be able to inherit from it. Okay? Sometimes parents do that for their kids. They design their life and their savings and so forth so that it is inheritable, right? Somebody else doesn't take it. Software the same way. We design software so that it can be inherited and then reused. This code reuse is very, very important. So we can add attributes and methods in addition to what's already there. Diagram, picture worth 1,000 words here. We have the class automobile. Pickup is an extension, isn't it? It's a specialization, inheriting all the basic fundamentals of what we consider to be an automobile, and adding some extra characteristics, pickup. What's the difference between automobile and pickup? Pickups have engines, they have wheels, they move, they transport. So do automobiles. So what's the difference? One's more specialized. Pickup maybe is heavier, has a bed to it, has more weight that it's able to handle, a bigger engine or bigger, better gearbox or some such thing as that. Is that clear? I don't want to beat a dead horse, but it's so important. Notice in the diagram, the arrow is going back, not down, but up. When we talk about inheritance, we're always saying, I'm referring back to my ancestor. I'm using what's already there and extending off of it by specializing. So this is inheritance. This is called the base class up here, and it contains features that are common to all of these guys. Now,